Good afternoon, students. Now, in this class, I am going to take a new chapter in operating system, which is processes in operating system. We have already discussed in 3 classes the basic concept of operating system, different functions provided by operating system, properties of operating systems, and types of operating system. Now, next, in this class, I am going to discuss one of the most important concept of operating system is processes and its different states, its different functions, and how operating system manages processes. So in this chapter, I'm going to discuss different activities of operating system, different activities of processes. So first, we should know what is process. So a process is basically a program in execution. Okay, a program in execution is known as processes. The execution of process must progress in a sequential fashion. So sequential fashions mean one by one. So a process is defined as an entity which represent the basic unit of work to be implemented in the system. So a running program is also known as process. To put in a simple term, we may also consider when a program is loaded into the memory and it becomes a process. Remember, when a program is loaded into the memory to be executed, then it becomes a process, and it can be divided into 4 sections: stack, heap, text, and data. The following image shows how the sections are defined. Stack, this is stack sections, and it is free space, then heap, then data portions, and text. Ultimately, these 4 sections are seen in the memory space. Next, if we see the components and descriptions of these 4 sections, stack, the process stack contains the contemporary data such as method, functions, parameter, return address, local address. So contemporary data is actually contains in the stack. Then what is heap? Heap is a dynamically allocated memory to a process during its runtime. When process executing in the runtime, then some memory space is needed. So it is allocated dynamically by the process, and that area is actually nothing but heap. Then text in this section includes the current activity represented by the value of program counter. We know that program counter keep track of the process or program next to be executed. When one process is executing, then program counter keep track the address of the next process to be executed after completing the previous one. So this includes the current activity represented by the program counter and the contents of the processor registers. Now next, data portion. So data in this section contains the global and static variables. So related variables, it may be global or static, local, all are stored in data portions. Now, so we have already know program. A program is a set of instructions, set of lines. So it is, we have already know. So a computer program is a collection of instructions that perform a specific task when executed by a computer. So we have already know this. When we compare a program with process, we can conclude that a process is a dynamic instance of a computer program. So when program is in executing state, then it is become process. So program and process are different. Actually, program is a static entity, we might say, but process is a dynamic entity. So dynamic instance of a program. Process is nothing but a dynamic instance of a program. So a part of computer program that performs well-defined tasks is known as algorithm. Algorithm we have already known. That algorithm is stepwise solution of a program. So a collection of computer programs, libraries, these are the basic concepts. So we should know what is algorithm, what is software, what is program. Then it is clear to understand the process. Now process life cycle. So when a process is created in the operating system, it passes through several phases, several cycles. So these are also important. When a process executes, it processes through different states. These states may be different with respect to operating system. So in general concept, there are 5 states. So first is start or begin state. This is the initial state when process is first started or created. Okay. Next is ready. So ready means the process is waiting to be assigned to a processor. So ready processes are waiting to have the processor allocated to them by the operating system so that they can run. Process may become into this state after start state. So after passing the start state, it is come to the ready state. While running, then it but interrupted by the scheduler to assign CPU to some other process, then again it become ready. So third state is running. When the process has been assigned to a processor, when a process is assigned to a CPU or processor by the operating system scheduler, the process state is set to running and the process executes its instructions. So running state. Then fourth is waiting. Process moves into the waiting state if it needs to wait for the resources, such as waiting for user input, waiting for file to become available. So for some reasons, when it needs to wait, then process comes to waiting states. Next, terminate state or exit. So last phase or last state is terminated or exit. Once the process finishes its execution, it is terminated by the operating system. It moves to the terminated state where it waits to be removed from the main memory. So in this way, we can see the states, 5 states model. Starts from start state, process are created, then ready. Okay, after ready, it goes to running state. And from running state, if no problem, then completing it is running by the CPU and it's terminated. If some problem, then it becomes waited state, and then again from waited state it go to running state, it goes to ready state, then become running. So remember, from waiting state it don't go to running state, they are again go to ready, then running. This is the main concept. And after running, if it completes, then terminated. So this 5-step model is very important for the processes. It is very important for exam also. So now come to one important data structure of the process, where process all required information of processes stored. That is nothing but process control block, PCB. It is important where all required information, essential information are stored in for a process. It is one kind of data structure. We can also say storage area. So a process control block is a data structure maintained by the operating system for every process. Each and every process has its process control block. The PCB is, that is PCB, process control block, is identified by an integer process ID PID, unique identification number. A PCB keeps all information needed to keep track of a process which are given below. So what type of information is given process control block? We can see the information in this block. Number one is process state. So we have already discussed 5 states: start, ready, running, waiting, and exit. So this type of information, what type of state is in the process, the current state of process, whether it is ready, running, waiting, whenever, these are actually important information keep in process control block. Next, process privilege. This is required to allow disallow access to system resources, means whether it will be allow or disallow to access by the or execute by the CPU, or whether it will stored in memory or not. This process privilege also important information which is actually stored in process control block. Then process ID, unique identification number. It's otherwise lots of problems. So each process has its unique identification number, process ID, in the operating system. So next, pointer, a pointer to a parent process, because each process has its parent process, so it should be linked with the parent process or other process. That is why a pointer is needed. Next, 5 type of information. Program counter. Program counter is a pointer to the address of the next instruction to be executed for this process. So program counter we know already. It is a register, or sometimes you can also say as a pointer which keep track the address of the next instruction to be executed for any processes. Next, CPU register. Here CPU register where process needed to be stored execution for running state. So CPU registers are also stored in PCB, process control block. Next, CPU scheduling information. So different scheduling information, process priority, other scheduling information which are required to schedule the process are stored in process control block. CPU scheduling information also important information. Next, memory management information. How memory is managed by the processes. So this includes the information of page table, memory limit, segment table, depending on the memory used by the operating system. So memory management information also stored in process control block. And accounting information. This includes the amount of CPU used for process execution, time limits, execution ID, etc. This accounting information also important. Then IO state information, input output status information. This includes the list of input output devices allocated to the process. So in this way, basically this type of information are stored in the process control block. Now the architecture of a process control block is completely depending on operating system. So different operating system has different process control block structure. So they may contain different information in different operating system. So it is depending on what type of operating system, what type of information of processes is process related is stored in process control block. So in simplified diagram, simple in general, following information are stored in process control block for every operating system, basic in general. Number one, process ID, process state, pointers, priority, program counter, CPU register, input output information, accounting information, etc. These are the attributes of process control blocks. So process control block maintains a process throughout its lifetime and deleted once process terminates. So process control blocks, for process, each process has its own process control block, and if no need, then it deleted. This is about the process. Now I think you understand this. Okay, again we may take some slide also to know remind you about the process, so please go through this information also. So process state, this content process description, process control, this next. So process, from the processor point of view, we may say process executes instruction dictated by program counter, so and interleave the execution of various processes. Again, from individual's program's point of view, process is nothing but executes a sequence of instruction within that program. So in this way also we can define. Now you see how the snapshot of example instruction, how process is stored and how program counter is actually keep track the process. So suppose this is main memory, 3 processes are there. So this is dispatcher, the small computer program. So process A, process B, process C. So dispatcher is also here. Starting address is 100. So and program counter keep track of the address of the processes, that the instructions that to be executed next. In this way where we can see how processes are stored in main memory. So next, already we have discussed 5 states. In sometimes there are 2 states also, 2 states process model. Process may be in 2 states, running or not running. So enter, not running, dispatch, running, and some problem occurs, not running, and exits. The 2 states model. Actually this is now 5 state model is very essential. So 2 states model is when we have. Then how not running process in a queue state? So when lots of processor comes, then enter the queue and dispatcher take the high priority process or number 1 process to the processor, and processor execute. If completed, it goes to exit or terminate state, otherwise it paused and enter into again ready queue. So queuing diagram of the processes. Next, what is dispatcher? Dispatcher is a computer program which moves the processor from one process to another. Means dispatcher take the process to the processor, moves the processor from one process to another process, and select a process from the queue to execute after interrupt or process termination. So it select processes from the queue to be executed. If interrupts occurs, then it terminates. Again it becomes queuing. So dispatch also prevents a single process from monopolizing the processor time, so that dispatch also help by utilizing the proper timing for a process. Now process creations, we create lots of method created by OS priority service process to control printing. This and lots of processes are created by operating system. For example, some system calls for the process is created by operating system at explicit request of another process. Fork, so fork parent process creates child process. Related processes need to be communicated and cooperate with each other. So process, when we come with concurrency control of processes. Process terminations when it's complete. So batch of issues, halt instruction, user log of white applications, error and fault condition. These are the process termination condition. Again, some reasons for termination of process: normal completion and limit exceeded, memory unavailability. bounds violations, protection errors, arithmetic errors, time overrun. These are the reasons how process, when process is to be terminated. Reasons for process termination: input-output failure, invalid instructions, privileged instruction, data misuse, operating system interventions, such as when deadlock occurs, so process terminate, and parent terminates for this of his child process terminates. So parent request, etc. Now we have already discussed the 5-state model. So some processes in the not running state are ready to execute, whereas other are blocked. So dispatcher could not just select the process at oldest end of the queue. Dispatcher would have to scan the list looking for the process and need to split the not running state into 2 states. Okay, ready and block. So finally 5 states. So running, ready, block, new, and exit processes created but not these are already we have discussed. So a process, this is the same 5-step model. So exit, a process has been released from the pool of executable process by OS. So this is important. So new means start, admit ready. So dispatcher will take running, and after completing release and exit. So if some problem, timeout or other event waited, then blocked. Again from block it occurs event, and then it come to ready, then again dispatcher take for running. This 5-step model we have already discussed. So this is also a single block queue. How admit, ready queue, dispatcher, processor, release, then timeout or whatever, then block queue, then again from this admit the ready queue, and this is also actually how processes are queued and when they and how processes are taken by the processor. This is also some this structure also actually describes the 5-step model. This similar happen. So admit, release, ready queue, dispatcher take processor, release, again some event occurs, it again go to ready queue. For every some problem intervention, then blocked, and this is block states. Again from block state it is to go to ready queue, ready state. So suspended process. So I think today I have stopped my class, and next class I will cover process scheduling. It is another important concept of processes. So process and its different synchronizations problems, huge topic. So today I stop here. Okay, thank you very much.